Hello everybody and welcome back to Expert.js. My name's Abrar and I'm going to be your instructor for this video. In this video we're going to be talking about numbers. Just like strings, numbers are a fundamental data type in JavaScript. So let's get right to it. So first of all, what are numbers? Well, unlike strings that we just learned, numbers are written as is, with or without decimals. So in order to write a number in JavaScript, you just write it as is. In this case, we have the number 1, 2, 3, and then we end the statement with a semicolon. We don't need to put in quotation marks or anything like that around it. We just write the number as we usually would. In this case, we have a whole number because we don't have decimals. It's just 1, 2, 3, which is an integer in JavaScript. You can also use decimals. So in this case, we have 253.87. And this is a decimal or a fraction number, which in JavaScript is described as a floating point number. Now, just like strings, you might see a number created using the new number syntax. But again, this uses the number constructor in order to create a number object and not a number primitive. You don't need to use this method because just like the new string method, it's not effective, it's not faster, and it's not efficient. It also has various side effects. And because JavaScript automatically gives you access to all the properties and methods of numbers, you don't need to create a new number object. So avoid using this syntax as almost always it's a bad practice. In JavaScript, we also have scientific notation. So 45e4 actually means 45 multiplied by 10 to the fourth power. In this case, it's 450000. So, unlike strings, you write numbers in JavaScript as is. Don't put in quotation marks around numbers because otherwise JavaScript will actually treat them as strings and not numbers. Now at this point, you might be thinking, well, we can write numbers inside strings as well, right? Then why do we need a different numbers data type? And that's because the numbers written as strings are actually treated as strings and not numbers, which means the different methods available to numbers are not available to numbers written as strings. Also, certain mathematical operations can be done with numbers written as strings. They can only be done on the numbers data type, and that's why we need numbers. Now, JavaScript can also have negative numbers. In order to write a negative number, you just put in a minus symbol in front of it. So minus 5 creates a negative number. JavaScript also has the word infinity. The keyword infinity is what returned when the result calculation returns infinity. For example, if you divide a number by 0, infinity is what JavaScript will return, and infinity is also a number. You can use the typeof operator in order to find out the data type of a certain value. In this case, if you type in typeof and then 1, 2, 3, 4, 5, but enclosed in quotation marks, as you can see on the right hand side, it outputs a string because it's actually a string. Although we have 1, 2, 3, 4, 5, because we have quotation marks around it, it's actually regarded as a string. But if you type in typeof 1, 2, 3, 4 without quotation marks, then JavaScript outputs a number because this is a numbers data type. There's also the special keyword NaN. N-A-N stands for not a number, and this is what JavaScript will output if the calculation results in not a number or the calculation is not valid. You'll see more examples of NaN returned in later lessons. Now, JavaScript numbers are actually only accurate up to a certain digit. In this case, normally, JavaScript numbers are accurate up to 15 digits. So if you put in 99999 up to 15 nines side by side, it's regarded accurately. But if you put in 16 nines side by side, JavaScript actually rounds it up into 100000. So be careful with that. Now, just like strings, when you write a number as is, you're using the number literal syntax and it creates a number primitive. And number primitives can't have properties or methods because they're not objects. But just like with strings, when you create a number primitive, JavaScript automatically creates an instance of the number object, and the number primitive inherits all the properties and methods of the number object. So you have a lot of properties and methods available to numbers. Let's take a look at a few of them. First, here are some numbers you can use when working with decimals. The first method is the toFixed method. Now, the toFixed method can be used to take a number and actually output it with a specific number of decimals. In this case, we have the number 3.4, and we use the toFixed method. And inside the parentheses, we tell JavaScript the length of the decimals, in this case 4. And JavaScript will return the number as a string, but with the specific number of decimals. In this case, 3.4 gets turned into 3.4000. So we actually have 4 digits after the decimal, because JavaScript padded the number in order to include 4 digits after the decimal. Similar to the toFixed method, you have the toExponential method. The toExponential method also accepts a parameter, which is the length of the digits after the decimal, but it also uses a scientific notation along with it. So in this case, 4.27 to exponential 5 returns the number as a string, but with 4.27000. So after the decimal, we have 5 digits, but then we have e plus 0. So it uses the exponential or scientific notation, and also at the same time allows you to specify the number of digits after the decimal. We also have the toPrecision method, which takes in a number and it can be used to specify the exact length of the total number. In this case, toPrecision2 is the total length of the number we want. So 5.74, which actually has 3 digits, but if we use the toPrecision2, we have returning string, which is 5.8. So 5.78 has been rounded up into 5.8 because 5.8 has 2 digits, which is what we specified in the toPrecision method. Do note that these methods actually turn the number into a string. So if you want to use the output of these methods as numbers for different calculations, you need to convert them into numbers again. Now there are a few methods of the number object itself as well. One of them is the isFinite method. The isFinite method will tell you whether a number is finite or not. In this case, you use the method by writing in number.isFinite, and inside the parentheses, you type in the number you want to test. In this case, 17 is definitely a finite number, so isFinite returns true, as you can see on the right hand side. But if we type in isFinite and then 45 divided by 0, which is infinity, then isFinite returns false, because a number divided by 0 is infinity, which is not finite. We also have the isInteger method. The isInteger method will tell you whether the number is an integer or not. In this case, isInteger 67.247 is definitely not an integer because it has a decimal or a fraction. So in this case, it returns false. We also have the isNaN method. The isNaN method can be used to check whether a number is nan or not. In this case, isNaN nan almost returns true, but isNaN a certain number would return false. So in this case, we have isNaN 45, and because 45 is definitely a number, isNaN returns false. There are some properties available of the number object as well. One of them is the max value property. So number.maxValue will tell you the absolute maximum value JavaScript can normally work with. And it's a very, very big number, as you can see on the right hand side. We also have the min value, which is the lowest positive value JavaScript can work with. And it's a very, very small positive value, as you can see on the right hand side. Now, oftentimes you might have a number as a string. So in this case, let's say we have a number 34, but it's actually wrapped around in a pair of quotation marks. How do we convert this string into a number? So how do we convert the 34 string into the 34 number? In this case, we can use a method called parseFloat. The parseFloat method can be used to convert a string into a number. In this case, inside the parentheses, we input the string we need to convert. In this case, we input 34, the string. And on the output, as you can see on the right hand side, it actually outputs 34, but without the quotation marks, which means it's been converted into a number. Parse float can also accept decimals. In fact, the parse float method is actually used for decimals. So 4.87, the string, actually returns 4.87, the number, using the parse float method. Now, if you input a string that's not actually a number, in this case we have inputted parse float boat, then JavaScript can convert boat into a number. So it just outputs nan. So it's just one of the examples where JavaScript outputs nan because it's not a number, because the operation is invalid. JavaScript can convert boat into any number. There's also the parseInt method, which actually gives you an integer. Now, it's a bit less flexible and complex than the parsefloat method, but it has its own uses. The parseInt method actually accepts two parameters. The first one is the string you want to convert into an integer, and the second is the base you'll use. Now, there are a lot of bases used in computer programming. The most common one we use is base 10. Base 10 uses numbers from 0 to 9, and this is the normal number we humans use. So in this case, you can input parseInt for the string, comma 10, and it'll use the base 10, which is the normal human numbers, in order to output the for string as the for number. Now the parseInt method can't work with decimals. So in this case, unlike the parsefloat method, if we type in 35.7, the output number is only 35, so the 0.7 has been completely ignored. So the parseInt method only outputs integers and not floating point or decimal numbers. Now, as I said, the last parameter can be used to define the base. In this case, normal humans use base 10, but computers use binary or base 2. And if you have a number which is a binary string, you can actually convert it into a number using the base 2. In this case, we have parseInt, and inside the string we have 101, which is a binary number as a string. And using base 2, we have the output 5. 101 in binary is actually 5 in human base 10. So you can use the parseInt method in order to actually convert a string into a number with a different base, something other than base 10, like base 2 or base 16.